Hi, and welcome to the Unreal Engine News and Community Spotlight. So for our first order of business, we're going to talk about our August NVIDIA Edge winners. So we had some really fantastic submissions this month, and it's always hard to narrow it down to just 3, but we have to. So let's take a look at our first winner. It's Gokun Karadai. He actually made a procedural ecosystem environment. It's 16 kilometers square, or a 16 kilometer square map that's all rendered in real time, and it just looks phenomenal. He actually has a number of different environments for different seasons. He has a winter, summer, and I think a fall, and they're just stellar, and he kind of shows you how to break them down and use them, so make sure to go check it out. It's really sweet. Our second NVIDIA Edge winner for the month of August is a small apartment tour project by Virtual Arts. They just walk through this quaint little apartment, and it's really well lit. I love the decor, the textures on especially the fabrics just look stunning. I really want to cozy up in that bed. It's awesome, and it's really well laid out, and so huge shout out to them and their team. Our third Edge winner is Diode, and it's all done by an individual named Alden Fillion. So you're wandering around in the land of Diode, and it's a third-person Metroidvania action-adventure game, and you're exploring, battling, and solving puzzles, and just searching for the secrets as you check it all out. He's an industry veteran, pretty confident he's doing a good chunk of this project all by himself, so that's pretty spectacular. So congrats to all of our NVIDIA Edge winners. They're getting top-of-the-line hardware from NVIDIA, who's our fellow sponsor or partner in this program. If you want to check it out, or if you'd like to submit, tag Unreal Engine at Unreal Engine and NVIDIA Developer or NVIDIA Game Dev, and we'll find those projects, and maybe you can get some sweet hardware next month. So, NVIDIA Edge. For our second news item, we have a blog written by Nick Whiting, and he's our technical director for AR and VR. So, and a number of individuals put this blog together, and it's how to actually get started in ARKit. So if you have an iOS device and you maybe saw the Wingnut demo that we did at WWDC, maybe you want to make some cool people running around on a table or jumping off and getting attacked by battleships. That'll get you going. It may not show you how to do all those steps, but dive in, check it out. It's a really useful resource as lots of people are starting to get into AR. And speaking of AR, Google announced their ARCore on Tuesday, and so that's Android or AR support for Pixel, the Pixel SL, and the Samsung Galaxy S8. And so if you're excited and wanting to do that on Android, definitely check that out. There's a developer preview, and there are going to be a lot of features coming in 4.18 that support all that. So you can do more AR support in Engine, and it's awesome. And I'm really excited to see all the AR projects that are going to be coming out in the near future. So that's our news. Onto the community spotlight. So this week, for our weekly karma earners, or top earners that are doing really wonderful things in our Answer Hub, helping people out, we have Victor Burgos, had 205 karma points. We have Shadow River, Ninjin, Daniel Orchard, Noctmare, Nuclear Arbiter, Affirmian, Benn Vladki, Cannibal, and Sealin. So again, thank you all so much for supporting your community and hanging out with us. So our first spotlight for this week is another architectural visualization done by Avocado Salad. So it has a very Scandinavian feel. He's working on a lighting study with this environment, and it just looks so spectacular, you guys. Like, I want to move into this little apartment too. I know it's just the beginning of their project. They're going to flesh it out and add more furniture and all this, but I just wanted to say it looks wonderful, and I want you to keep going, and we're excited to see the progress on this piece here. Our second spotlight for this week is a skin study. So they're actually using the Project Emily model, and they have done the textures, height maps, and they actually did all the work for the eyeballs, and this looks stunning. I thought it was a photo at first when I scrolled by. It's almost on the edge of being one of those kind of eerie wax people, but it looks amazing, and I'm really pumped for where we're going as far as photorealistic technology, and this is clearly a great start, and we're really going places. And our third and final community spotlight for this week is Treeview Studios' Alchemist Defender VR. So it's a tower defense strategy game, and you're going to be balancing VR tower defense mechanics with first-person combat using melee and ranged weapons. So you're going to be this master alchemist on his quest for the Philosopher's Stone, because what else does any alchemist want in their life? And you're going to defend your enemies, or defend discoveries you make in the game from enemies that are trying to capture these secrets from you. This game looks alike, just so much fun, and I really love how they're utilizing that balance between a top-down or more like tower defense game versus a first-person view. You haven't seen a whole lot of that in VR, or some, but it's something different that we get to try in VR. So, looks awesome. I'm excited to check it out, and yeah, do that thing. So thank you again for joining us for our Unreal Engine News and Community Spotlight. Welcome to the Unreal Engine live stream. This week's going to be focused on animation and physics updates in 4.17 and maybe a little 4.16. So I have Lina Halper, one of our senior animation engineers with us. And then in the nice little bubble over there, we have Benn Gallagher, who's sweet enough to stay up late in the UK to join us. And he's one of our programmers working on that too. So thank you both for joining.
You're welcome. Thank you for the invite.
So first of all, before we dive in with them, we're actually going to be doing a giveaway. We have a few keys from the game Mid-Air. They've just gone into early access this last week, and it's a game where you use your jetpack and frictionless boots to fly around, and it's a 16 by 16 or up to 16 by 16 team-based combat. So they were kind enough to hand us a few keys. So over the course of the game, or over the course of this stream, we'll have a pop-up come up, and whoever snags the key first gets it. So every man for himself, snag those keys. But we won't tell you when they're coming. All right. So thanks again, and feel free to hop to it.
Jump into the presentation. So we have a small presentation covering 4.16 to 4.17 features. And so the biggest part, first part is, okay. So the first beginning, the huge portion was clothing tools, which basically Ben worked on, and he worked on tools and solver and we're integrating solver and everything. So he's gonna start talking about it. It's a lot of items, but we have lots of video and stuff, so hopefully they'll really help. So Ben?
Do we have Ben?
Oh.
He's hiding.
Sorry,
It's okay. Can you hear me?
I can hear everything.
Okay,
Cool.
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 So Ben, yeah.
So yeah, we've been meaning to move away from the clothing system we had in Unreal for quite a while. It was quite a big SDK that didn't really serve us perfectly because there was an awful lot of it we either weren't using or were underutilizing. We found some benefits we could get by shifting to sort of a more low-level solver, taking on more responsibility ourselves, making the clothing less of a black box, so we understand it more and we can do more with it. So we worked with NVIDIA for quite a while to break out the core essence of the clothing solver into a new product called NV Cloth, which is part of their GameWorks library. It's a much lower level solution than Apex. It just covers the core particle solver, and then we can do everything else on top that Apex used to handle for us, and then we can cut out some of the chaff, some of the stuff that we don't use, and we can add more to it. The idea was to build a new extensible framework around clothing, so we could keep adding more and push for better clothing simulations and more realism. This gives us more control in UE4 and again more scope to do interesting things. If we have the actual particle solver, we can do some really cool things like animation targeting or just having direct control of the simulation in a much easier manner than previously with Apex. Do we go to the next one?
Yeah.
So we got some benefits when we switched over as well. The configurations tend to be more distinct. If anyone's looked at the clothing level in content examples, you'll have seen these examples on the right there before, and quite often they look very, very similar, especially with the old Apex solver. And that's down to a few different reasons. The setups used some quite esoteric parameters that maybe we didn't get 100%, and there was some extra things that weren't exposed there. So once we've exposed those all out and learned more on the low level what that solver is doing, we can create more distinct simulations and distinct items. So we've got on that there, it's supposed to be burlap, silk, sort of rubber and heavy leather, and they do sort of act differently. It is much better in motion, so check that out if you're interested in clothing. And the good thing with us building an extensible pipeline, the clothing before was sort of really wired in at the low level to our physics system and our skeletal mesh system. It's now been broken out in such a way that if someone was researching these kind of things and had a cool new clothing solver, or if someone wanted to go beyond sort of game physics and have a really accurate solver, it's quite easy now to write your own solver, integrate it into our system and run it in Unreal. You literally just change a drop down once you've written your solver, and that just works. And you can run them side by side, so you can show improvements as well. Currently, we only have the NV Cloth solver there, but it gives us options in the future. Go ahead again. So it gave us some other options as well. It allowed us to take over authoring. So the authoring pipeline before was to go through a DCC tool with a plugin to generate your clothing, which it worked for us for a long time. We use clothing in Paragon, and we've used it a long time before we developed this system. But now that the authoring is completely detached, we don't have to use the Apex authoring SDK, which was again a little bit of a black box, a little bit hard to deal with, and something that we'd never tackled before. This gives us the option to try and do it ourselves, because now we have to own all the data. We don't have some magic asset that just gets imported to the engine to work. We hold everything, so it gives us much more flexibility. We haven't removed the ability to use Apex. You can still create those in the DCC tool of your choice and import them through the new clothing tool, but it just gives us more options. If you don't have access to that, or you don't want to use it, if you find that there are pipeline problems with that and you prefer our pipeline, yeah, you can use ours, but the option's still there. The actual aim of doing this was to reduce iteration times and remove dead time in the pipeline when you're importing backwards and forwards from DCC tools. The main issue we found was that if you had to do a tweak to clothing, that meant going all the way back to to the DCC stage, and if that required a geometry change on the actual mesh, that might mean you need to re-import animations, and there could be a lot of work with a severe clothing update, and we were using it on quite a few characters in Paragon. So this was the core aim of making our own tools. And so this is a quick sort of diagram of what the pipeline used to be. You would always export your FBX and your APX side by side from your DCC tool, so that would come from Maya or Max or Blender or wherever you're developing your characters. The Mesh Geo came into the engine, and then you pull in the APX to get your clothing data. You'd have to get in there, have a look around, make sure it actually works, visualize it, check it over. And if you found that you needed a parameter change, if it was a simple parameter change like gravity or stiffness, you could do that in engine. But if you needed to change your simulation mesh, or you needed to change how far it could move, or how your backstops worked, you had to go all the way back to your DCC. And that was long enough because you had to context switch, go over there, do your stuff, export through, back out. But again, if you needed to do a geo change to the original mesh, that could be much more painful. And if we move on, we'll see the new pipeline. So you only do your export once. You have your geo. You will export your simulation mesh with that into the engine, create your clothing in engine, and you do all your parameter changes, and then you can visualize and check, and you can do this iteration really tight inside Unreal Engine, never having to switch. The only time you'd have to go back to your DCC is if you need a core geo change. So we've removed most cases that would require going back to DCC. And so this is still an experimental feature. So in 4.17, you'll need to go into your editor preferences, experimental, and enable clothing tools to be able to see it. And then it appears inside the skeletal mesh editor in the window tab. There's a quick video that shows how we can quickly set some clothing up in about 30 seconds. So Clint, if you want to run the clothing tool video. So here we've just got a simple asset that has no clothing at all on it, and we can now select that and create clothing if we want from it. I do already have something sort of prepared, so we'll apply that to it. And simply in the new clothing panel, you can get the painter up just like you would in a DCC tool. You can paint it with a brush, but in this case, we've already written a gradient tool that can do a nice smooth gradation for us. So we quickly just mark this mesh up. Green points represent the beginning, and red points represent the end of the gradient. All these things are configurable on the details panel to the right that appears when you enable clothing, when you enable painting, sorry. And once that's done, we show over here, this is where the values are for the gradient. We can just hit enter, and there we go. We've got some gradation, and that sets itself away. And that's a simple clothing setup. It hasn't been tweaked, but it's an awful lot quicker. Here it is in World. It's an awful lot quicker to use this than it is to do a full route through the DCC. If you just want something quick to see what it looks like. And there you go. It's just moving around.
It looks so great.
It's so cool.
So yeah, that was obviously very, very quick. We've got like 100 things to get through today, so I can't do a full walkthrough on how that tool works. But it is cool. It's still experimental, so it may change. I think we're changing the UI up a little bit for the next version. But yeah, if you want to give it a try and see what some of your characters look like with clothing on, it's available there.
Yeah, folks were asking if we were going to be updating the UI soon. So
yeah,
it sounds like that's
4.18.
4.18 will have some updates for that. Great.
Yeah.
Awesome.
But yeah, I think the clothing itself will need a whole stream just to explain how you can really tweak, how you can utilize all the tools, right, Ben?
Oh yeah. The tool is quite large. I keep adding things to it, and our Tech guys always want new things. So yeah, walking through how we create our clothing would probably take some time.
Well, maybe we'll just have to get you back for that.
To Ben.
Anytime.
Yeah.
All right.
Okay, so next one.
I'll
guess
keep
Ben.
going on this one because I put this one in. It's so the preview scene we recently, I think it was back in 4.15 that we moved the preview scene at this advanced preview scene where you could have scene probes for lighting with HDR maps. We've done a few upgrades to it now, so the preview mesh is now accessible on the toolbar, just so you don't have to go digging in the tabs. The collections are now optional. Before, if you wanted to change a preview mesh, you had to have a collection asset, which was a little bit awkward to maintain. So that's now optional. You can preview just locally, and if you want the preview to update for your colleagues, you can then create the collection. Just a quality of life improvement. And we've now moved, we did have some preview settings still with the viewport settings. They are all now all in the preview tab, so they are much easier to get to, and you don't have to remember where was this feature over here or in the different menu. It's all in one place now.
Cool. So so we are going back and forth between me and Ben. I'm gonna talk about some other features. The first one is the spline IK. It got added with the 4.16, but there hasn't been much of exposure on the feature. So this is it basically is like a spline IK in Maya, where you have a spline that you dictate where the line goes, and that's what joint is following too. And it gives you roll, twist, start and twist and values. You can like try to control the where spine is rolling. Clint, do you have a video of the? So I just made a quick video. We do have a video. We do have a, if you Google spline IK, you can actually find this. But it didn't really explain the whole thing, so I just made another video. You just said spline IK. You picked start joint and then end joint. And then if we just compile, it's going to auto-generate the point. If you look at it, you can change the number of joint. You can move the joint. If the control point, we call control points, and you can even expose them to be. Now I'm making like I think like more numbers, not auto generate. So you can actually add more joint, more points, control points in that point, and also you can control them. You can expose as parameters. So you can actually have a word spline curve that actually dictates each control point. You can hook that up. We also have a twist roll value exposed. You can use those values to control the how much upper body twist compared to the whole the torso twist, and you can do all those things using spline control, spline IK. It's not only for spine; it can be for a lot more, and we are still working on more of things. But yeah, try out if you haven't seen it. I think we have some improvement, maybe some polish or UI work, but it's gonna be pretty cool. So the next one is there are like some small changes coming to Tubon IK and look at. So just quick things in the look at thing was the so like some of the visualization before it was very hard to see what exactly is happening, but now you can see better. Also, you interpolation like delay or some options are more visible now. You can see the clamp value and then how much it's delaying. So it's just a little bit of improvement to the tool to see what's happening. And then, how do I go? Okay, that's good. I wasn't sure. Okay, Tubon debug option. So now you can just check the enable debug draw in the Tubon IK, and it's gonna show the plane of the where the plane or it is, and then where the joint target is. So you can actually visualize what's happening a lot better.
That's wonderful.
Yeah, it's just there's some tools things, but it just helps to because when you see it, you can actually tell what's going on.
Yeah, it's way easier to figure out what you're trying to do.
Yeah. Before just having that, like you're like something's happening. So this one, just one option added for the like a twist option, because often what happened was you're targeting something, your joint is all twisting, and you don't like that for like especially robots or the rigid meshes. So you want it to not twist. So that's this option basically. It targets it, but it doesn't twist. My arm twist, but in that option,
right? Yeah,
you don't twist. So it's just option, but it's good for like I guess the robotical kind of like a robot rigid body stuff. So it's good. The things coming up, like this is not a huge thing, but just to give you heads up, things like bone and socket is interchangeable. will be like more of target, effective target, joint target. All of them will be more like the same interface. And location will be more like offset from that location. So now location is used for world position, but the target is used for something else. It's gonna be all same interface. We'll get some interpolation improvement, but that's coming up later. This is for Benn.
Yeah, so I think it was Yura, who's one of our other engineers on the animation and physics team, who put this together. But it's cool. We use it for. We've been talking about sort of post-import stuff that you always want to do to post-process an animation or an asset before it's ready to go into the game. So in the case of if you had a running animation and you want to play particle effects when it hits the floor, you probably want something like maybe a notify on the footfall when it hits the floor. Really, instead of if you have like 20 characters, you're gonna have to go and do that every single time. Whereas it's possible to automate that kind of feature. If you know which bones are the feet, you can look at their low points and place that. That's just one example, but adding things like curves or notifies that are automatable will save time for content creators. So we put this together. You can run a modifier whenever you want. You can also undo the modifications that a modifier can make to an asset. There's a new window in the skeletal mesh editor. I think actually all of the animation editors have this. You can create a modifier either as a native C++ class or as a blueprint from animation modifier, which is the parent class, which does nothing. It's just an empty class for you to target from. And then you can either implement your native or your blueprint. So this small image at the bottom here is a very simple one that just adds a new anim notify track for generated notifies and then adds a new notify to it.
Yeah.
But this can be done for loads of different things. We can have footfall notifies. You could add some generated curves to track time, or you could generate virtual bones on your mesh, on your skeleton. We've added a bunch of new editor-only functions that you can call here for doing things like adding notifies, curves, virtual bones. So there's a small but core suite of things you can do there that we'll probably be expanding in the future.
Yeah, people who've been wanting to import to notifies, they can import the curve and use this to create the notifies.
Yep.
That would be cool. So
this is a bit more of a complicated example. A lot of these graphs are collapsed down because they are huge. Well, not quite huge, but quite large, not bigger, a bit too big for a slide. So what this one would do is on apply is when the user decides to apply them. We would grab all of the bone transforms. We would find the lowest point for each bone, and then we would find the frames where each bone is on the lowest point. Then we could add sync markers for the bones that we care about. So if you had two animations that sync during a run, you could add sync markers to that at the low points for the feet or the hands or whatever you want to sync. And then you could add some curves to control that later on. And all of this stuff, without this feature, you kind of either have to do manually or write some engine module yourself. Now you just write a quick blueprint that does it for all of your assets when they come in.
cool.
This is another one for me.
Yeah.
We've also been looking at expanding the compiler. So I think Tom Sarkinen, another one of our engineers, put this together. It's an experimental feature as well. So you'll have to go into the experimental menu and find enable live recompilation of animation blueprints and use that. This just allows for greater iteration. It also allows for good interaction with. So in Paragon, we have our animation blueprints, which if you're in the animation editor, just sit idle because they're designed to work with other objects. They're designed to work with actors or characters. And sometimes it can be kind of hard to debug that because you have to restart your instance every single time. So allowing these to recompile live allows us to change them while they're running in-game. So I think we have a video of this one as well, the live compile video.
Yeah.
So you can see here we've got our content examples open with the Owen character. The one on the right is what we're watching here. So his blueprint is telling him to play idle at the moment. So I'm going to go to the blueprint for that and check out the state machine. I'm going to try and get him on screen as well so we can see this actually working. You can see that it says simulating. You've got the yellow border, which normally would mean that you couldn't compile this. and have it work. So there's the add animation. We will swap that out for like a walk forward animation, hook that up and compile it, and the running game below will immediately update. So this is in simulate mode, which is essentially just Pi. It's running game. It would work in any other way when you're running Pi. So in this case, it doesn't matter too much because that blueprint is incredibly simple. But the more complicated blueprints that interact with characters and other actors can be a pain to debug without something like this.
Cool.
Cool. Back to the slides.
Awesome.
And more. This one is, we've had a bunch of physics optimizations. So ARCore, our physics guy, has been looking at a bunch of different stuff for 4.16 and 17. So we've added async cooking, so you can cook off the main threads, and that kind of helps a little bit while doing a normal cook. But we have a runtime cooking plugin now. So it was sort of a compile switch, so turning it off and on was a bit awkward. So it's now a plugin, and that can run async, so you don't have to run it on your main thread. We've also started to look at batching physics tasks, so this makes better use of our task graph. We create tasks which are small bundles of code which go onto this big graph that runs on multiple threads. This will batch multiple things together so you don't have the overhead of spawning lots of smaller tasks. We did some work for kinematic updates. So kinematics are if you have a physics body that is connected to a bone in a skeletal mesh, and the animation is controlling that bone. The rigid body on top of there is called a kinematic, so it's controlled by the animation. That has to happen at some specific sync points. So we do try and keep that performant because it can be a hotspot. So we've done some work there. We've also done some work with raycasts to make them a little bit faster against complicated geometry or sort of areas where there's lots of geometry bundled together.
Cool.
Cool.
Okay, so in the forum, actually this wasn't on the list yesterday, but there were a lot of questions about this one, so I added it. So this is Ori Cohen who did this rigid body node, and we call this immediate mode. And what that means is actually, if you know our engine, there's a tick order happening, and tick order has a pre-physics, post-physics, like during physics. And what the during physics is when every physics simulates in that time frame. But immediate mode allows you to simulate without going through that pipeline, which helps a lot because now you don't have to wait for physics to be done. You don't have to wait for physics to do all crazy things after that. So that's why we call immediate mode. It's like you simulate right now when you want. So rigid node basically use the system to simulate inside of animation system. And so it's the animation node that simulates physics during animation evaluation. And it uses just physics asset. It doesn't need a separate setup. It uses physics asset you have. And works with the animation system. Right now, we are still working on making it more like a blending better with other system. But as of now, like you can just make a physics asset and you can just hook it up to simulate, and then it just works. It's localized simulation because we are not going through normal physics simulation, and it's simulating locally. You don't work with anybody else. So say like you are working with a static mesh, like a static mesh works fine. But if you say like you have one character, the other character, both are doing rigid body node, they're not gonna interact with each other.
Okay.
So it's more like just to it's localized, more like fancy stuff, but not really. We don't care about collision.
Gotcha.
So and the last one I meant more like a custom simulation option. If you look at how this node works, you can actually create your actor to simulate something inside. If you want to just create a custom actor.
Mm-hmm.
And then say like I have all these crazy things I want to simulate, and I have like this 10 bodies. So I just want to edit that to one of the scene I have, and then I just simulate. And you can do that. So it has a huge potential to opening up the simulation option for a lot of people. So it's not just for animation node, but that's an example of how we propose to be used. But you can create your custom actor to do all this crazy immediate mode to do it. If you look at the rigid body node code, you can probably figure that out, like how that's used. And this,
if anyone's used to using anim dynamics, this is like an expansion on that concept that can hopefully work in a lot more situations.
Yeah, anim dynamics were awesome, but the problem was it had to do separate setup, and it was a lot more setup, so it was difficult for some people who are not used to it. So this one makes it easy for you because you can see physics asset simulating, and you can see that in the anim node. There is documentation for this soon. We don't have a really good. We have a video of working. We are working on better version of demo, but like right now, if you look at just to create the rigid body node, you see like there's like some cache coming up, and the rigid body node simulates. And usually, you mark those bodies that you want to simulate as a simulate. So you mark, like say you have ponytail, you just mark in your physics asset, pick your body and say simulate, then it's gonna simulate automatically after all the animation. And you can do even like after simulating, if you want to do IK, you can do that after this node, right? So because this outputs some pose, so you just can do like IK after that, or before you couldn't do it because this runs and then physics runs later, and then later something happens. But now it makes it easier. So check out. We are still improving the blending part, so. But it's gonna get better. And there are like lots of miscs I added because I'm like I see so many features. I'm like it's so cool, so I want to add it. This is all from our team. Like our team called NM Physics. Ben, me, Tom, Ural, Martin, James, and Ori, and everybody. So anyway, so play montage blueprint node. This is just a blueprint node that actually you can trigger from anywhere, and it's like related to like move to. If you have AI, say move to, then this AI goes, and then once you get there, it does something. And this is something like that. You say play montage, and it's gonna do all the things inside, and then when it come out, when it's done, it's gonna say done, or blend out, or it's interrupted, or some notify happen, then it can even trigger that. So you can do a lot of things in the blueprint. This was Laurent Delaine. This one is, I just wanted to show this demo because I think it's so cool. And Ori doesn't want to show, but I want to show. So, so if you look at the hand in this video, hand is kinematic. So animation is driving the position, but you can simulate everywhere else. So it's kind of cool because hand is almost fixed. And oops, what's this whole? Okay, but hand is fixed in this video because the animation is driving it, but now everybody else can simulate, which is cool. This is what they meant by the.
You can right click and loop if you want it to keep playing.
Oh, okay. So the reason the Ben just talked about kinematic bodies. We have a simulate body in the physics asset, and then we have a kinematic body. Kinematic body tells you follow animation. Simulate body tells you, okay, now you're simulating. But the connection between them is always very tricky to handle. And this this was a really cool thing because there were lots of issues with the feedback happening because kinematic is moving and generating velocity, causing the other body to move. And like it had a feedback. But this one, he improved a lot, and this one made it really cool. So anyway, so check out. And then if I go back, how do I go? Okay. So the other one was export to animation using preview mesh. Create is less important probably, but before we had the issue where like if we have like all anim dynamics in the viewport, if you export, nothing exports because we were not exporting what's currently happening. We are only exporting the source data. So you didn't see it, but now you can export to using preview mesh here. Then you can do like retargeting info or all the post process happening in engine will export to with it. So it just makes it it just makes it a better option. And now you can actually sort by folder in the SF browser, which is really cool. Tom edited this in
like
Epic Friday, I think.
little quality of life things that
Yeah, it is. It's one of those things. Like the reason I want to edit this is like people won't ever notice. So this got edited, so it's cool. So you can do filter by folder, so it's cool.
awesome.
Preview additional mesh using copy pose. So the one Ben explained before about preview options, all the new preview options, that's really cool. Preview scene option. But now this one used to be like using master pose, but now it's using copy pose. And what it allows you to do than before is, before the problem with the master pose is if you don't have the same joint structure, it didn't work. So if we have like a head that has all weird crazy joint, then you couldn't see it. So this one lets you do all crazy combination of like say you have like a leg that has 3 legs. You can hook up to that. Or like you can do it's not that crazy, but like you can go a little more than what your same hierarchy as master. Before master slave was, if you don't have the same hierarchy, that doesn't work at all. But now it's just better. This one is a dynamic additive node. So this one was came from licensing. Somebody, do you remember who that was, Ben?
No, I'm not. I can't remember.
Okay, so somebody basically, you can create the additive animation all the time, but this one make you create additive in runtime. So, and then you can hook up stuff. So in here, basically I made additive from idle pose to heel reaction and apply it to the jog. If we have an exact same setup like I do right now, you probably don't have to do this dynamic additive because you can just create the animation. But if you want to do some very crazy setup and you want to create those additive, apply those additive dynamically, that's when you want to do. So anyway, that's it. Are we good on time?
You crushed it, yeah.
Oh no, I didn't crash it.
You got 15 minutes left.
Oh yeah, so we have Q&A.
Yeah, there's some questions up here if you want to check in.
Yeah,
So,
right.
yeah.
What is
Let's
good?
see.
So the first question we had from forum was, what is a good way to preview morph targets in the editor viewport? So I think we fixed this. I'm pretty sure it's fixed in the 4.18 at least, for sure. But 4.17, you couldn't see the morph target, but now you should be able to see morph target. If you don't see that, it is a bit kind of tricky because before you have to create the blueprint and then you have to like trigger from construction script, and that didn't even work well. So, but 4.17, 18 should fix it. So hopefully that's gonna work. The second question is any montage, UI improvement. So Tom is a wizard on editor. It's our all tons of like just editor wizard for all animation features, and he has a huge plan for. The goal is looking like a sequencer. It's not like the same as a sequencer, but all the timeline, everything is gonna basically come to animation editor, and it's gonna get all UI overhaul for it. But it is still planned. We don't know exactly when yet. I expect sometime next year, but so that's planned. UI is a bit ugly right now, but blend space got a little bit of a update, so I think next one will be the timeline stuff, a lot of curve editing. Right, Ben? Do you have anything you wanna add to?
I know. We've wanted to change that for a while.
I know.
It's been stuck around for a while. I mean, I think even the notify panel we want to change because it was all sort of custom drawing code. But yeah, like hopefully we can take some lessons from sequencer and make something that's more like a linear tool rather than whatever it is we have now.
The sequencer curve editor is gonna basically looking like that, but yeah, we'll see based on timeline. The next question is, so somebody asked about the constraint profile. So somebody was asking about how you set up characters constraint profile. If we haven't used it, the physics asset editor has like profiles, and you can swap to different profile for constraints. So say, for example, you have a normal physics constraint between this arm, and when they die, their constraint profile might change to break or just go release. Will capsule still be not following? This is a bit weird, but the capsule will always follow where root is. So I'm not sure exactly what you meant by will capsule still not follow the mesh after going to regular. That always root moved from physics simulation, it's gonna follow. If root is not moving, it's not gonna follow. So that's, but yeah, the question was a bit confusing.
I think I've seen some people before end up not moving the root in the animation, and it's quite an easy thing to miss, and then your capsule will stay.
I guess the tricky part might be if your root is not at the root body, if you have a root body is in the pelvis or something like that, but we fixed a bunch of issue with it. So if you see some issue with it, you can probably just post somewhere and solve up. Will probably better way to handle this situation, because from this sentence it's a little bit confusing question. So the next question, is it possible to move the render mesh independently of the collision mesh? So I think this one is asking, when you have a character with a capsule and skeletal mesh, can you move skeletal mesh out of capsule? And you can totally do that by just having the relative transform separate. We do this
actually, because I look at this question, I think it's more, can you move the skeletal mesh but leave the bodies from its bones
oh dear
in the right place, like offset the render, which we can't do right now.
No, that you can't do. If you do that, you can do it if you change the engine to have offset for each body. So
I think one of the easiest ways to do that would, there might be a workaround if you have two skeletal mesh components. One of them has physics, one of them doesn't, and then make one of them invisible. You won't actually pay the draw calls, we won't actually generate them, and you'll be able to separate them that way.
Yeah, I guess, that's one way to do it. Or maybe you should do the master slave. So slave has the offset. I don't know, but if you want to do per body, that's still tricky. Right? Yeah. So anyway. Oh yeah, the next question is for Benn. The gradient tool used to paint the class points. I noticed you select all red vertices individually. Will we see the box select? It's marquee select for editor windows like this?
We don't have marquee select right now. We do have, if you've got a large amount of verts to pick, there's a checkbox there that says use regular brush. That allows you to sort of like paint the red ones on with a larger brush rather than one at a time. But yeah, marquee selection, as soon as we can, we wanted to make some improvements to how the mesh paint works. It's been in its current state for quite a while, and we've got some performance concerns, and we have obviously endless feature requests for what we could do there. So that's something that might come along in the future, but not entirely sure when. But we are aware that the mesh paint needs a bit of work there, and we do have plans for some time in the future.
Cool. Next question, can we interpolate control points to create animations?
Yeah, you should be able to drive those from your event graph.
Yeah, you can. Just if you've seen the picture from before, you can just feed that as a input parameter, and you can do that. I think what might be easier is to just create a spline component and just to head the control point and feed that value to. Then it's just easier visual. Next question, with the control rig plugin for UE4, are there any plan to add support to manipulate and animate fingers? Oh my God. So the control rig is changing everything. So we are redoing a lot of stuff. So we don't, that feature was experimental back in like March or April. That is probably not gonna, we are working on like changing code of system. So we are not gonna probably change the rigging. The goal is to let you rig, you guys to rig really beautifully. So we don't have a plan to add fingers yet. If we want to add fingers, because fingers, I get that you can either use IK or you can have some kind of pose blending, some pose blending system between fingers. So you can generate something like that. But since we are changing everything with that, we are going to add other system to support the feature, but I don't think we are gonna improve that current existing one. So next one. Is there a reason why the any blueprint Kismet compiler does not support output pins other than F-pose link? Oh, is it because it's not needed often or is their technical limit? So any blueprint, any graph, event graph has a sequence. Action comes in, do something, and it goes out. Do something, it goes out. Any graph doesn't work like that. Any graph works as like a tree system where you have a bunch of stuff coming. It does go through different kind of paths than any normal blueprint does. So we don't support like a sequence of actions. We do support this graph that works with initializing, updating, and evaluating. And they work, they follow the chain in certain order. However, they don't work like play animation and then do something else and do something else. It doesn't work exactly like that. It works a bit different. It looks like a similar sometimes, yeah.
Yeah, the tree's sort of updated conceptually backwards. We start at the root, and then we follow all of the different paths. And if something's not weighted, it's then just ignored. And then we end up with this big list of things that need to be updated, and then it just goes through.
Yeah, so we cannot support output like normal blueprint because they don't have a place to go. We are not gonna call them, so I don't know what they're gonna do with it. So if you look at any other blueprint, there's event coming up. So something happens and do something, but everything graph doesn't have that. So not really. Okay, so next question.
The best way to kind of do that is if you need to respond to, if you're responding to animations, you can respond to notifies in your event graph. But yeah, anything like skeletal controls really don't support that kind of that's a kind of event triggering at all.
Yeah, like you can do like you can call some functions like get curve value, but that also has some flow in terms of like update and evaluate because pins are updating in the update. Well. Yeah, so it is a bit tricky. I wrote blog post about this initialize and update and evaluate one time. So if there's just 3 different stages for animation, and what's happening in each stage is a bit different, and that is it's beauty of like I guess animation system the optimization and everything, but it is one of the difficult part of understanding the system. But yeah, I think maybe if Benn, if you're up for it, another blog post maybe can help.
Yeah, sure.
So next one, does raycast optimization affect the entire engine? For example, using a raycast as a bullet, for example. Oh, 2, for example.
Very much an example.
Benn, what do you think?
Yeah. It's, I mean, they are fairly general improvements. If I remember correctly, I did take a look at the changes recently. I think it mainly just helps large queries. So I think if you were shooting into a very complicated area, say you had a big stack of barrels or something, and you wanted to know which one you hit, I think those sort of situations are optimized. But yeah, it's more of a general thing. It's not a specific. We haven't found a specific a hard case where it was really slow. It's just some like small little micro optimizations that'll every little helps. So in some really complicated circumstances, you might be able to notice a bit of a drop, but it's nothing game changing. It's just small improvements. Hopefully, if we make enough over time, that'll come down and down.
Okay, so next one, will there be a possibility to bake a dynamic simulation in editor? I'm not sure if he's talking about any other simulation. If we are talking about like a clothing simulation, we cannot bake it, right?
No, we can bake dynamics though using
we can
recorder.
Yeah, the recording feature, you can just bake any other simulation like rigid body or even physics editor simulate. It used to have a record button. I don't know if that's gone, but it used to have a record button, so you can record it to any animation.
Oh, okay.
So if any joint motion, you can record. If we are talking about clothes or something else, not really yet.
Yeah, we haven't got a playback cache for clothing. It's interesting though. I've never hit the need for that. But yeah, definitely with joints. Just not
Maybe
clothes.
we just support to Alembic export. Export to all to Alembic.
Yes.
So maybe that's one thing. Rigid node, I'm not still sure about the use case. I feel like this is really helpful to whatever it's made for, but my imagination is a bit limited right now. I mean, the easy example is replacing anim dynamics. Ben, do you have a good example, right?
Yeah, so the way I explain it is if I'm not sure if everyone's familiar with Paragon, but the way that we use it on that project is for any sort of active bodies. So if you have a character, who shall I use? So Feng Mao, he has a ponytail. He has these leather straps hanging down from his ears. He has armor on his legs that he's got tassets made up of 3 different loops, 3 different plates. He's got some clothing on the front and the back. What else has he got? He's got this big chain on the end of his weapon. So all of that stuff, we could animate it painstakingly, but certain things like chains or maybe even the tassets themselves, they just wouldn't animate correctly. You wouldn't see anything that was, you would see things that don't physically make sense. So what we did instead is we had Anim Dynamics and now Rigid Body come along, and what you would use is you would define all of those things as actual physical bodies, never animate them in your animation toolkit, and you just animate the rest of the character and let that motion move the bodies around. It's a nice way to add sort of secondary procedural motion to a character without having to spend a long time sort of hand animating them. Sometimes hand animating it just isn't possible.
So yeah, just to the easy example is secondary motion. The more advanced example is the one I was talking about, simulating in one of your system. Like if you want to simulate in certain time, do something, then it's more advanced feature. But yeah. So next question: what performs better, traditional additive animation, dynamic additive? Oh, traditional additive animation. It's because if we are talking about performance, dynamic additive is doing the delta calculation in runtime. Where if you do additive now, in editor, it creates additive, and then it bake that data to the delta track, gets baked to the separate track, and it's the low track, whatever the complex track. So you don't have to recalculate the delta when you extract it. But dynamic additive will just let you do that in runtime. So that's what I meant by, if you just have one animation, want to create the additive, you just create that in editor. You don't create using dynamic additive. If you want to just test something between different options, maybe you can do that. But dynamic additive is something you have a pose that you cannot create you don't have SF for. You want to create the delta between them in runtime. That's what you want to do. So it's not for performance, it's more for the flexibility of the feature. You need this feature for something for your game needs. So I think that's That's my
Yeah.
answer.
We made it to the end.
Yay!
Thank you so much, both Ben and Lina, for joining us. This is
are
very
alive.
much a interesting topic, and that a lot of people have been biting at the bit to get updates on. And if you're happy to, we'd be more than overjoyed to have you back and dive a little deeper into some of these topics. I think a lot of the folks are really excited to
I
hear
keep
from
making
you.
clothing too.
So,
Because
in
it's
release 2, that'll be ready.
It is a huge thing, and people think we have a team of people. We have a Benn. We have one guy
Yes.
working
The
on
Benn.
everything from like in and out to tools to everything. So it is a huge thing. So what I mean is but it'll be amazing. Like as he said, it lets you let us create the tools for it. We can tweak parameters, everything in engine, and we have more option to do, like integrating another solver to it. There are more options, so it opens up huge door for us.
Yeah.
So anyway, that's gonna be awesome for 4.18. And the other things coming up, if we can talk about something coming. Physics.
Sorry.
No, not yet. No. We are not talking about what's coming. I guess one thing I just want to mention is Tom has been working really hard to make physics editor working. So now the old physics asset editor is gonna change it to get whole new look in 4.18, and he's been working really hard for it. But it's gonna look awesome. It's gonna look cool, and it has all new features. Like you can drag stuff and then you can do stuff. So it's gonna be cool.
That's gonna be great.
So anyway, yeah, there are a lot of things coming from
Good.
our team.
So
Awesome
be
team.
excited for all the work that they're doing. Thank you again for
Thank
coming
you.
on. I did
problem.
frequently drop a survey into the chats, so if you have feedback for us on how we're doing or what you would like to see in future streams, jump into that survey. We'd love to hear from you. A couple quick notes. We have game teams and Unreal Engine biz folks are out at PAX, so if you're in Seattle, come say hey. We always love to chat from you, see you guys in person, and just know what you're up to these days. And if you're in Raleigh or Cary, we actually have our Unreal Engine meetup tonight out at Craft, so come hang out with us. We'll be chatting and drinking and hanging out. So thanks again for showing up, and we'll see you next week.
Bye.
Bye.
See you.